Okay, the concept of today is the multiplication rule for vectors, so-called vector product or cross product of two vectors. In Finnish, I will write this concept in Finnish. Vektoritulo. And the other word is ristitulo. This tulo in Finnish means same as product or multiplication, and vectory is vector, and risti is the same as cross. The name of this multiplication rule comes from the point that the result of this vector product will be vector. If we compare this for example to dot product or scalar product. Scalar product was called scalar product because the result of that multiplication was a scalar or simple number. So it was not vector, but in this case we get the result which is also vector. We multiply two vectors with each other, and the result will be also vector. And the name cross product comes from the sign between those two vectors. There will be, or that it is not a dot, but it is actually the same kind of, like in the calculator we use this cross there. So the calculation rules, I will first write. We can calculate the cross product with the many ways, but I give you first the calculation rules. It is probably easy to remember the rules by using some kind of figure. At least myself, I remember the rules when I write these unit vectors I, j, and k, and we are having a cross multiplication there, and the positive direction around this cross mark there is the clockwise direction. This is plus direction, and we can understand this so that when we take two vectors I and j and we are going to positive direction, then the result from a vector product I cross j will be plus k. I cross j will be plus k because we are going to positive direction. And also when we multiply j cross k, we will get result with this plus I. And the third possibility is k cross I, and we get result plus j. So this is positive direction. And the negative direction is counterclockwise direction. If I write it here, this is a negative direction. So if we multiply j with I, j cross I, and we are going to negative direction, we will get result k, but it is minus k. And also I cross k, and we are going to negative direction, we get result minus j. And the last one, k cross j will be minus I. So the rules will be I cross j is plus k, j cross k equals plus I, and then the last one, k cross I equals plus j. These calculation rules is good to understand because some cases where we have to do this cross multiplication, it is much more quicker to calculate that vector product by using these simple memory rules. There are also another way to solve the cross product, but it is a little bit work. We have to work more to get the result. So in some cases, this is more simple one to use these rules. And then the negative direction, I will take them in opposite direction. Chi cross I, k cross j, and I cross k. And as we saw there, we always get the third letter. So in this case, j and I we get k, but it is negative. Kj we get I, but it is negative. And ik we get j, and it is negative. And also there are three other choices to make the multiplication, and that is that case where we multiply vector with itself. So I cross I, this is zero vector. J cross j is also zero vector, and probably it is easy to understand this is also zero vector. So here it actually are all rules we need to remember when we are cross multiplication. We are doing cross multiplication between two vectors. I will take an example, and then I will get another method to calculate the cross multiplication, and that method it is. In that case, in that way, it is easier to use. That you don't actually need to memory any these kind of things. You just do it like a mechanical way, but the price of that way is that it is always a longer calculator method. For example, let's take example, and of course I will take one or two applications also. Where do we need these cross multiplications or vector products? Let's say we have vector A, which is 2I plus 3k, and B, so this is vector in three-dimensional space. There is I and k component, so it is x component and z component. And this B vector will be, let's say, minus j plus 4k. Of course, they can be whatever like those vectors. And when I'm going to do this cross multiplication, I will write them in that order. A cross B, that is 2I plus 3k cross minus j plus 4k. And this is a very easy method. This is exactly like we did in algebra course, or you have done in your life many times. I will multiply these by multiplying first these two here. So that will be 2I cross minus j. Then I will take this multiplication plus 2I cross 4k, and then this one plus 3k cross minus j, and the last one is the last one here, plus 3k cross 4k. So first I will check the factors there, or those numbers in front of those unit vectors. I have here 2 in front of I and minus, or actually minus 1 in front of j. 2 times minus 1 will be minus 2, so this will be minus 2, and then there is I cross j. And we can see from that table here, I cross j, it is exactly the same as k plus k. Or from this figure, I, j, and we are going to positive direction, we will get result k. So this here will be k. And then the next one, there is 2 and 4. 2 times 4 equals 8. And then there are I cross k. And from that figure, I can see I and then k in this order. I, k. When we are moving from I to k, we are going negative direction, so we will get result j, but with minus sign. And here also we saw I cross k equals minus j. So this will be minus j. Here again, there is 3 times minus 1, that makes minus 3, and k cross j, which will be, from this figure, we are going from k to j, we are going to negative direction, and we will get I with the minus sign. Or from this table here, k cross j equals minus I. And the last one there, 3 kertaa 4, 3 times 4, 12, and k cross k. Well, here we have a case where k is multiplied with k, so as we saw here from memory rule, this will be 0 vector, so actually it's the same as 0. So this will be cancelled out from the calculation. So the result will be minus 2k. 8 times minus j will be minus 8j, and minus 3 times minus I minus and minus, that will give us plus 3i. And if we want to write this in alphabetical order, ijk, the final result will be 3i minus 8j minus 2k. Or in bracket form, 3 minus 8 minus 2. And as I told in the beginning, that this product is called vector product, and that's because the result is always a vector, as we saw. We don't get the simple number, but vector. Well, this is one way to solve this cross multiplication between two vectors. But there is also a little bit more mechanical way. this is actually, I don't like this method here, because there are so many intermediate steps there, and there are many possibilities to make errors there. So actually I don't like this method, but this is best method when we have very simple vectors. For example, if we had such a simple vector that, for example, in this case we did not have this k part here at all, only 2I, and with this method it is very, you can get the result by in your head. You don't actually need to write any intermediate steps to get the result. But I will solve this problem also with another method. So let's take another. One with another method. So we had this vector A 2I plus 3k, which actually in this bracket form is 2. Then there is not this second component at all, so it will be 0, and the third component is 3. And then B, it was minus j plus 4k, and we see that in this vector we don't have I component, or the first component, at all, so it will be 0. The second component is minus j, so it is the factor in front of j is minus 1, and the third component is 4. And now when we want to calculate the vector product of these vectors I cross B, we can use this with the help of determinant, and we will use determinant 3 times 3, or a determinant which has 3 rows and 3 columns. So I will write it like this. First is unit vectors I, j, k in the first row, and then these components 2, 0, 3 in the second row, and these components of the second vector to the last row, or the third row, 0, minus 1, 4. And if we use so-called Saru rule with when calculating this vector product, or calculate the value of this determinant, we copy the 2 first columns. Actually, we can make this with the two possible ways. We either can copy these 2 first columns and write it after this determinant to the right, or we can copy the first and second row and write them below the determinant. I will choose the first method, so I will copy this I, j, 2, 0, 0, minus 1. So the first columns will be copied there. And then with this Saru method, Sarrus method or Sarrus rule, we will have this positive direction. So this is the positive direction we are going from. As in the Western world, we are used to read a book. Here I will take Here is the history book. Travel to Mongolia. And when we read these books, we start from this part of the page and we go through the page and end to this part. So we are going actually in this direction. And that is the positive direction here. And this means that we have to multiply these with each other. And as we can see, there is 0 in the multiplication, so actually we don't need to multiply this at all because that will give us 0. And then the second multiplication will be this. And here also we can see that there is 0 in one of the components of this multiplication, and that will also give us 0. But the third multiplication will give us something different from 0, because there are no zeros in that. And we can see that this will give us minus 2 times k, or minus 2k. And as we see here in the answer, there actually is that kind of part in the answer. This is the positive direction. I will write this first one here will give us 0 vector, and the second one will give us also 0 vector, and the last one will give us minus 2k. This was the positive direction. Then I will take another direction, which is negative direction. So I will use here blue. I don't know how well you can see the color, but this is blue color. And this is negative direction, and as we see here, we have actually 2 zeros. So this will be very 0. This is the result of this multiplication. And this is negative direction, so I will take minus sign here and brackets. So all these will be subtracted from the first part. So here we got 0, and the second multiplication will be in this way. There will be 3 times minus 1, minus 3 times I, or minus 3i. We got minus 3 here. If we compare from the result in the previous example, we got plus 3i, but we can see that there is this minus sign in front of those brackets, so this will change the sign to plus. And the last one will be this multiplication. There will be 8j plus 8j inside of brackets, but there is minus sign in front, so it says that minus 8. So the result will be minus 2k plus 3i minus 8j. The same result, a little bit in a little bit different order as here, but the final result will be the same when we arrange them in the same order as we did earlier. So this is 3 minus 8 minus 2. Same answer. So this is the method how you calculate the vector product or cross product, and now I will get some kind of practical application, or at least some kind of application. We can use vector product. Of course, there are many applications, but in this course I probably will take only two most usual applications. We can use vector product, for example, to calculate areas. And I will get an example where this grid paper to be able to draw a little bit more nice picture. Write first the number of the page, so I will not forget in what order I had these examples. And let's take example 2. And I will draw a picture. Again, I will first do an example where the area of this triangle is possible to calculate actually in your head, so you don't actually need any vector calculations there, but you can understand that if the triangle is in a little bit nastier form, then this method will help you a lot. So I will draw this kind of picture here. There's coordinates here, x, y, and let's say that I have here 3 points in the figure. Here we have the point A, and here we have the point B, and here we have the point C. So I will draw a triangle there. And the problem is the area of ABC. So as I told that this example is so easy that we can see from the picture what is the result, because I am using the grid paper, and I can see that the base of this triangle will be 7 units. This is 7, or actually I can measure from my 7 units or 7 centimeters in my paper, and the height of the triangle is 4 units. So the area is easy to calculate by 7 centimeters times 4 centimeters divided by 2. That will be 14 square centimeters. But how do we get this with the vectors? And of course you have to think that this vector method is useful actually when the coordinates of that picture are more tricky than in this case. In this case we have simple numbers there, whole numbers. This A has the coordinates 3 and 2. Here is 3, here is 2, and the B has the coordinates 10 and 2. And the last one, C, has the coordinates 4 and 6. So now when we want to use vector product or cross product and use that to find out the area of this triangle, we have to choose some corner of this triangle. It can be whatever. It can be A, or it can be B, or it can be C. I will choose, for example, C. It is not maybe the first thing you could choose, or first corner you could choose, but I will take that C there. So I will select the corner C and create the vectors from that point to A and B. But as I told you, you can choose what corner or what vertex you like. So the vectors, vector AC, sorry, it's not AC, CA, vector which starts from C and ends to A. We will find the vector expression by taking first A's coordinates, so we will get 3 and we will get 2, and we will subtract the coordinates of C from those. 3 minus 4 and 2 minus 6. This will give us vector minus 1 and minus 4. And then the other vector CB with the same method. We subtract 10 minus 4 and 2 minus 6. So the coordinates of B minus coordinates of C. 10 minus 4 and 2 minus 6. Actually, if you did this in opposite order in both of those vectors, you will get the exactly same result. It doesn't change the result, because that would mean if I made error in the directions in both vectors, then that would mean that I did not have vector CB, but I had vector BC which goes in this direction. And also here I would not have vector CA, but AC. That means that it will go in that direction. And if I create, I have those vectors that they have same lengths and they opposite directions than these vectors here. So the triangle will be the same, or the area of the triangle will be the same. If I made an error in this order of subtracting. So here I get 6 and minus 4. And finally, we can find first cross multiplication. We can calculate it by this method. We use CA cross CB, and I will choose this determinant method now. I have I, J, K, and then I have these vectors. Actually, I have here only 2 components, but the third component will be 0, because this figure is in XY plane. The Z coordinate axis will go upwards from the paper like this. But when the triangle is in XY plane, that means that all Z components or all the Z coordinates will be 0. So actually, even though I did not write here the Z coordinates, they will be 0. So here we have minus 1, minus 4, and 0, the third component there. And the last one, 6 minus 4, 0. And if I use this Saru method, I will copy all again these first columns there, first two columns to the right hand side, and then just simply choose the positive direction. In this case, this is good that this is in XY plane. By the way, I'm all the time watching to camera, but as I told in the beginning of this lesson, my camera or that camera which I use in Teams, it does not work. I don't actually understand what is the reason for that. That is the reason why you can't see my face, but I don't know if you need to see that at all. But I have to tell that I many times check to the camera and see all the time that camera does not work. So here there is 0, and that will this multiplication will be 0. And the second one also, there is also 1 0 in the multiplication, so that will also give us 0. And the third one, that is the first one, which does not result to 0, we will get -1 and -4 multiplied with each other. That will give us +4 and k. So it will be 4k. And then the minus direction, we have here the negative direction, 6 times -4, -24k, and it will go inside the brackets. There is minus sign in front of brackets. -24k, and the second one, here we see that there will be 0. We are not going to write that anymore. And also the last one here, there is also 1 0 in the multiplication, so that will also give us 0 vector. So actually we don't have so much to calculate in this example, because we only have to take those brackets away. 4k and minus will give us plus sign. 4k plus 24k, that will give us 28k. So we did cross multiplication or vector multiplication. So the result is the vector. But we need to find the area, and this area is not any vector, it is a scalar. It has only magnitude and unit, in this case square centimeters. But this result is not yet the answer for the problem. But probably we can understand. We get 28, and here is 14, and this 14 is exactly 1/2 of this 28. And every time we are calculating something which has something to do with areas of triangle, we always have some kind of dividing by 2 or multiplication with 1/2. So in this case also, so that the result will be 1/2 of this number here. But this is not. We have to understand that in this case we had an example which is triangle in a plane, in an XY plane. We did not have those Z components here. But in a universal case, when we could have, for example, this triangle oriented in wherever in three-dimensional space, I changed the orientation of this paper, and if it is, for example, in this orientation, we could have there also those Z components in those coordinates, and usually we would not get so simple answer. Most usually we would get an answer which would be, for example, like this here, where we have all three components. But the answer for this problem is to that we get the answer for this problem by first calculating the magnitude of this vector, or if it would be like this, that vector, we would also calculate the magnitude of that vector, and then the magnitude of that vector will be simple number, scalar, and then we divide that by 2 or multiply with 1/2. So let's calculate the magnitude of this vector. First, I will write this in another way. I will use this bracket form. We have the first two components 0 because there are no i's or j's in the result of this cross multiplication. So we have 0, 0, and the third component is 28. So the magnitude of this vector will be CA cross CB, and we use the Pythagoras here, 0 squared plus 0 squared plus 28 squared. And you can see there is the 0 squared, those will be zeros, but in universal case they will not be zeros. There will be other numbers there than zeros. And actually right now we get only square root of 28 squared, and if we take that square root of the 28 squared, those exponent 2 will be cancelled, so this will be only 28. And the area of triangle, we get it by multiplying with 1/2. So we get the cross product of that vector, those vectors which start from whatever vertex of that triangle. I choose the point C here, vector CA, CB, and we calculated the vector product and the magnitude of that vector, and finally we take 1/2 of that magnitude. 1/2 times 28, that will give us 14 centimeter squares in this example. So this is the example where we can solve the example how we can solve the area of triangle. I think I will have a small break here. I have to save this recording of this first lesson. So I will take another example, which is an example of how we can use the vector product of vectors, two vectors, when by calculating the moment of force, and that will be the another application of the vector product. But let's have a small break. Let's continue at 15:10.